In this video, I'll be solving the integral of secant squared x over 9 plus tangent squared x dx. The first thing I'm going to do is going to rewrite this in terms of sines and cosines. Secant squared is 1 over cosine squared, and tangent squared is sine squared over cosine squared. Right now I see that there are two cosine squareds in the denominator, so I'm going to multiply top and bottom by cosine squared. So I'm going to cancel out the cosine squareds and be left with 1 over 9 cosine squared plus sine squared. At this step, I'm going to make a u substitution and I'm going to let u equal tangent of x. So du will be secant squared of x dx. I want to rewrite my integral in terms of u's. So what is cosine squared and what is sine squared in terms of u? In order to figure this out, I want to draw out a right triangle. I know that u equals tangent of x, so x is going to be the angle. Tangent is opposite over adjacent, so the opposite side is going to be u, the adjacent side is going to be 1, and the hypotenuse, using the Pythagorean theorem, will be the square root of u squared plus 1. Now I can substitute what cosine squared and sine squared are. Cosine squared is going to be 1 over u squared plus 1. Sine squared is going to be u squared over u squared plus 1. And I know that du is equal to secant squared x dx. So if I solve for dx, that's just cosine squared x du. And cosine squared is 1 over u squared plus 1. So that's why I have du over u squared plus 1. At this point, I see that the u squared plus 1 is in the denominator with 9 over u squared plus 1 plus u squared over u squared plus 1. But that u squared plus 1 is distributing to both pieces, both terms. So because those two terms have u squared plus 1 in the denominator, it's going to cancel out with the other u squared plus 1. So I'm going to be left with 1 over 9 plus u squared. At this point, I'm going to make another u substitution. I'm going to let u equal 3 tangent theta, and du is going to be 3 secant squared theta d theta. I'm going to replace the u with 3 tangent theta. Now I have my integral in terms of thetas. I'm going to use some algebra. I see that in the denominator there's 2 terms with 9, so I'm going to factor that out. And I know that the 3 and the 9 are going to cancel each other out, so I'm going to have 3 in the denominator. And 1 plus tangent squared can be rewritten as secant squared. So now there's a secant squared at the top, secant squared at the bottom. That's going to cancel out. And I'm going to be left with 1/3, which I can just pull out of the integral. When I find the antiderivative of 1, it's theta. And I'm going to add a constant. Previously, we made a substitution that said u is equal to 3 tangent theta. So my goal here is to go back and rewrite this in terms of u's. So tangent of theta will be u over 3, and theta will be the inverse tangent of u over 3. I started this problem in terms of x, so I need to go look back again to what I let u be. We said let u equal tangent of x. That was the first substitution we made. So I'm going to replace u with tangent of x, and I'm going to be left with 1/3 times the inverse tangent of tangent over 3, and plus the constant c.